So now we have completed JUnit, Mockito, Maven, SLF4J, Sonar. Okay. Now we are going to see the next very important tool, which is called Git. Okay. So this is very, very important tool where we'll cover this tool from today onwards. Okay. So how many of you know about Git? Just you don't have chat option, right? 1 minute. I'll call that name. So I just call that min. So they will be giving you the chart option access. So now we are going to see the next sixth tool, which is Git. How many of you know about Git? Or how many of you heard about Git? What is Git and all that? It is a code repository tool. Okay. It is a version control system. I'm seeing your messages. Project management tool. Okay. So it's a code repository tool and fine. Yeah. Common repository. Okay. All right. See, Git is actually code version control system. Control system. Okay. It is a tool. Okay. It is one of the tool. There are different version control systems. One of the tool used for code version control system. See, say, let us take, there will be in a project. Okay. There is a project team. And this project team contains, say, multiple developers. Okay. Developer, they operate in their own machines. Okay. See, developers, they write the programs and they develop for the project. So developer 2. Next is the developer 3. Next is the developer 4. Like that, they operate on their own code. I mean, they write the code. And finally, see, they cannot save their code in their machines. Okay. What happens if this machine crashes? So whatever developer 1 has developed the code, he will lose that. So what happens if developer 2 machine crashes? So developers develop their code in their local machines. local machines, but they cannot save the code permanently in their machines. Right? Because what happens actually if the machine crashes, so they cannot save. And also developer 1, developer 2, developer 3, developer 4, they will be working on, say, different modules. Now, as a project, all these modules should be combined as a project, right? So there should be one central code repo. One central code repo which stores all the code files of developer. So there should be one central code repo which stores all the code files of developers. So that means, so there should be one kind of a server. There should be kind of a server where developer 1, developer 2, all they can push their code to this server. Now this server will be very huge server. Even if the server will have backups. It is not like your laptops or your own personal machines. Even if the personal machine crashes, then it will be very difficult. But even if server crashes, you can restore your code from the backups. So this type of the central repository server is called code version control system. And why it is called version control system means, see, multiple versions of the code can be maintained here. So multiple versions of code can be maintained, and so what will happen is, say for example, say we developed a.java, and this has been pushed to the server with version 1.0. Some new features have happened. Okay, again we'll develop a.java, we'll update a.java, and again we'll push with version 1.1. So each version of the file that this server maintains, this code version control system maintains. Okay, so each version will have different features, will have updated features, where version 1.0 is the base version, version 1.1. So that is a reason it is called version control system. So there will be multiple versions of the code that can be maintained. Okay, and always we'll work with the latest version. But if you want to actually track the old version, okay, suppose if there is some issue with the new version in the production server, so what we do, so we go to the old version of the code and we again take the build using our Maven tool and again copy that to our servers. So in that way, maintaining the versions is the most important actually. Okay, so this code version control system will maintain, first thing, it will store the code for the entire project. Okay, instead of storing that in the developer machines. And second one, it will maintain the versions. So for each code that is actually pushed to this server, so it will maintain versions. So we used to have, there are two different version control systems actually. If I take, in the reality wise, there are two different version control systems. So one, so centralized version control system. And then next is a decentralized version control system. Okay, in centralized version control system, what will happen is, so there will be we call it as remote repository. Say we call remote repository. And in remote repository, this is a server. We can think this is a server. In this remote repository, so we can have like this. Okay, let me do like this. This entire thing is one server. Okay. So decentralized is also called distributed. Okay, I'll tell you. So this is a server. In the server, this can store multiple code repositories of different projects. Okay. Say I have a team who are working on project A. So I'll have a repository related to project A repository. Okay, project A repository. Okay, project A repository. Okay, now in project A repository, so what we'll have? So we will have, say, A.java, B.java, C.java. Okay, like that. Similarly, project B also will be there. Where a different team will be working on this, or same team is working on different project. Okay, so this is we call project B repository. Okay, project B repository. And here we'll have some X.java, Y.java, Y.java, okay, K.java, something like that. Okay, I'm just giving an example. Now this is a server. Okay, now this server will be connected from the client machines. Client machines are nothing but your developer machines. So this is your developer machine. This is another developer machine. Okay, this is another developer machine, or we'll have two machines. Okay, so developer A machine is working on project A. Who is working on project A? So what he do? He can actually only take the files instead of taking the repository. He can take what files he need actually. Okay, so A.java can be taken here, or C.java. So he can work on A.java, C.java. He can work on A.java, C.java. Okay, he can do the changes. Okay, and again he can push the changes back to there. Only the respective files. Okay, similarly developer B also. The developer B is also working on project A. Project A, and he can take B.java and C.java, right? B.java and C.java, and he can do the changes. First he can pull these files which are pushed by this person, developer A, and he can take whatever the files he need. He can do the changes, and again he can push that. So instead of storing that in the laptop, he has to every change developer has done. They have to push that to this repository. And in version control system, we have a special term called commit. Okay, I'll be telling you that what is commit actually. Okay, similarly project C. Okay. No, I'm just telling an example. A.java, C.java. He can take B.java also, not an issue. I'm just telling an example. Okay. So if you see the example here, so this project, so developers will be taking individual files from these repositories. Okay. Similarly, now we have another machine, developer C, and he is working on project B. He's working on project B, and he can take any of these files and he can do the changes, again push back. So this is what we call it as centralized version control. In centralized version control system, what will happen is So developers will be working with the individual files and they will push that individual files to the respective project repositories. Okay. So developer will work with individual files in their local machines and update the changes to the centralized version control system. Okay. Yeah, multiple developers also work on same file. That we'll see. Okay. They can work on same file. Okay. See, first don't go advanced questions because now we are starting, right? We are entering now into this topic. So just follow this. Okay. So first don't go immediately to advanced questions. Okay. So developers can work on individual files. The two developers can work on the same file. That is practical only, right? Suppose you are in one project, your friend is also in the same project. Okay, you both can work on the same Java file, right? So that is obvious. If the Java file is having 1000 lines of code, you will be working on 500 lines of code. Your friend will be working on 500 lines of code. So there is a practical scenario, right? But how that will be maintained, we'll see. Okay, how that this version control system will take care of two updates from the same file. All that we will see. Okay, when we study this Git actually. So now decentralized version system, what will happen is, so this is also called distributed. Okay, so this is also called, instead of decentralized, we call it as, actually the correct other name for this is distributed version control system. Distributed version control system. Okay, so now we have we'll have like, so this is a server. And say, now I have project A repository. Next, project B repository. Project B repo. And here we have A.java, B.java, C.java. Here we have X.java, Y.java, K.java. Okay, now we see. So now what we will have is, now this is your developer machine. Now here what we do is, say developer A is working on project A, developer B is also working on project A, and developer C is working on project B. Let us take this. So developer A, project A, developer B, project A. Project A. Okay, developer C. Project B. Okay. Now in distributed version control system, what will happen is, developer A who is working on project A, he can pull the complete repository to his machine. Similarly, developer B who is working on project A, he can also pull the complete repository to his machine. Complete repository. Similarly, developer C who is working on project B can pull this complete repository to his machine. Here, if you see, here they can pull individual files, like one file, two files, three files, like that. But here, the entire repository can be pulled into their machines. and they can work on the changes and again push back that. Here they can work on the changes and again they can push back that. Here, so that means if you see here, what is the main difference? If you see here, where they are working on the individual files, but here the complete repository can be pulled into their machines. Complete repository. And the main advantage of this is in the developer machines, each developer machine will have their own local copy of their repository set. Okay, so in the developer machines, they can have local copy of the repositories stored, so that even if they are working in offline, see, if you see here, compulsory they should be in online to push the code again, pull the code here to the server. Here, even if they are in offline for some time, that means server and clients are connected through internet or through some network connectivity. Suppose even if they are in offline also, these developer machines, what they can do, they can work in the local repositories. Okay, they can have local copy of the repository stored, and once they come to online, they can push the changes to the server. So that's why it is called distributed. That means in each of their machines, the version control system is distributed. That means the entire repository. When I say entire repository, including the versions. See, this repository contains a.java multiple versions. 1.1, 1.2, 1.3. Yeah, this b.java will contain multiple versions. 1.1, 1.2. So repository, when I say multiple versions of all these files. Here, multiple versions of all these files. Okay, entire repository can be copied to their developer machine, so that this developer machine will be a copy of this server repository, so that developer can actually do the changes and again he can push back that to the server again. Okay, so this kind of version control system is called distributed version control system. Okay, so with this actually developers can work even in offline also. So the repositories that are stored in these developer machines, those are called local repositories. Okay, the repositories. So the repositories that are stored in developer machines are called local repos. Okay, and this is called remote repository. So these are called remote repositories. So when we are able to copy this complete repository to this developer machine, means it includes all the versions of these files, all the files present in this repository, all the files with including the versions, all the files present in this repository. Similarly, developer B also can actually copy this complete repository into this machine, so all the files of this can be copied to this machine. But here it is not like that. They will only pull the individual files. Whatever files these people need, only those files will be pulled here. And they'll directly push again to the remote repository. Okay. But here it is not like that. The complete replica copy of the complete repository can be copied to these machines. So, and this is very popular version control system nowadays, and this is the older way of doing, and this is the popular way where nowadays we are using all this type of version control system. And the famous distributed version control system is Git. Git is very famous distributed version control system. Famous and popular distributed version control system. Okay, and okay, and there are different companies. Okay, they came forward and they provided implementation for Git. Okay, Git, so tools they developed for Git. Okay, in that popular is GitHub. Okay, and GitHub is popular. Bitbucket. Okay. Next is GitLab. So these are popular. So companies, they came forward, and these are popular Git version control. So they provided tools. So GitHub has provided a tool to which for implementing the Git version control system. So these are the tools, okay, developed for implementing, or we can say like tools for Git version control system. Okay, and in centralized version control system, the popular is SVN. So SVN is the popular version centralized control system. SVN. We call Tata is SVN. Similarly, VCS, CVS. VCS is also there. VCS, source safe. So these are all. So these are all actually SVN, VCS. These are all centralized version control systems. GitHub, Bitbucket, GitLab. These are all Git version control system, which is a distributed version control system. Okay. So in other words, actually, GitHub, Bitbucket, GitLab are the servers. I mean, so GitHub is one server, okay, which is used to implement Git. Similarly, Bitbucket is another provider for version control system. I mean, which implements Git. Similarly, GitLab is also another one which provides this and all that. Okay. Everyone clear? So the main advantage of distributed version control system is the complete repository can be copied to the machine, and even developer can work in offline without connecting to the server every time, and he can do the changes and push that again change back to the server. Any doubts till now? After modification, one repo, the old repo also there are deleted by developer. No, that complete repo will be there. Okay. And whatever the files it will be there. So see, modification will be done by the repo. They will push again that all the files to that repo. Okay. But it will not get deleted. It will be there in the same, in the developer machine. Okay. It will not get deleted. Okay. Now, Git is a open source. It is a open source. Okay. I mean, GitHub, Bitbucket, GitLab, these are all the tools that are implemented for Git version control system. So repository is a storage space. It's a storage area where all the code files for a particular project are present. So repository is a storage area, okay, where all the code files are present for a particular project. Okay. Now, so our topic is on this one, distributed version control system, Git, and I'll take GitHub as for the practical examples. Okay. So we'll not see with, so we are not going to deal with centralized version control systems. So we are going to deal with distributed version control system where Git we are going to use, and GitHub is the tool we are going to use, for version control system. So, for the server, for the remote server, okay? Instead of tool, I can say server. Instead of tools, I can say server. Okay. Now, so let us do deal like this, okay? Let us take this is a developer machine. It's a developer machine or laptop. So this developer machine has created a project folder in a C drive. In a C drive, some project one. This is a folder. Here he has put all the code. All the code has been copied here. All the code related to project one has been copied here. Copied here. Okay. So this is also called this part, whatever this path, this is also called workspace. Okay, workspace. So what is workspace? Workspace is a folder path. It is a folder path where developer puts all the code and works with the code. So where developer puts all the code and works with the code. Okay. Now that means, so this is your workspace. Okay. So in this workspace, the code is there. Code files are there. Now, these code files have to be stored in the Git repository. That is the goal. So for that, what we do is first, we have to add these code files, I'll tell you, to a staging area. Index or stage area. Okay. And then from here, we have to commit. We have to commit to local repository. So we have to commit to local repository. So from here, we commit the to, we push the to remote repository. Remote repo. And this can be your GitHub or Bitbucket server or GitLab, any version control system. Any Git version control system provided. Okay. And this entire thing, this is in one system, this is in server. And this is your, this is actually in the developer machine. So this is server. This is server. And this is here the developer. So workspace where your code files are there. Then we will add that to index or stage area. I'll tell you what is this. And from there, we will commit to local repository. And from local repository, we will push to remote repository. So to work with this, to add, commit, we have git commands. Git commands to work with this, to work with git operations. So to work with git commands, we need to have git installed. We need to have git installed in the machine, in the developer machine. We should have git installed. So once we have git installed in this developer machine, okay, so then we can actually use git commands to push that index area, okay, similarly local repository area and all that, and then push that to remote repository. Similarly, from remote repository, if you want to pull, okay, you can. So from remote repository, if I want to pull the files, okay, we use this called pull. So we use this called pull. Okay. So to work with this push, pull, add, commit, so we will be using git commands. And to work with git commands, we should have git installed in our developer machine. Okay. So how we'll install git in our developer machine and how we will work with these commands and do this, all will be seen from tomorrow onwards. Any questions till now? All right then. So tomorrow I'll be telling you that local repository, workspace and all that. Okay, wait till tomorrow. All right then. Thank you all. See you tomorrow. Tomorrow I'll tell you the installation and everything. Don't worry. Okay. Today is only the introduction class. Okay then. So tomorrow I'll tell you everything. Thank you all. See you tomorrow.